Hi there, this is Jacob Nash, Algebra Lessons, and this is Unit 4, Lesson 1 on the Introduction to Polynomials. So for me, this lesson is kind of like out of place because if you notice, this video was posted after all the other ones in this lesson because the original video was muted, and that's so annoying because basically I've been doing videos on math and engineering since the beginning of 2020, so really not that long, just like over a year. But I've had to experiment with the best places to do lessons, and originally I had some like slideshows for JNAL where I just basically clicked the mouse to draw because I didn't have any really good touchpad thing, and then I used a computer for the engineering lessons at first, but then I ended up switching to the iPad once I won a free iPad, well, 2 iPads from the radio station YFM, so that was pretty good. And a lot of other things. It was over $1,000 in gifts, so that's a big win. But anyways, this iPad has a screen recorder, but it's not always so good because if the iPad powered off, it automatically makes it muted when you're trying to make a video. You just have to remember, I have to remember to unmute it, so whatever. So this is an introduction to polynomials. So I have to remember that since this is out of order, that this should be the first talk of them. So the polynomials are just a set, it's basically an expression with various terms in them that can have different exponents on them, and depending on what they are, depends on what zeros you'll get, how the graph will look like, and end behavior, and how you can classify them, how you can factor them, how you can add, multiply, divide, subtract, all that. That's what you'll learn in this unit. But right now, we'll just look at how we can classify them. That's what we'll first look at. Then we'll look at how certain things can change how a graph will look. So, you know what a term is. So let's just think of an example here. So, you should know what a term is. So, this is a term, this is a term, this is a term. Okay? And then, the degree would be 2 because that's the highest exponent that there is there. There's technically a 1 here, and if you think about it, really a 0 there for the x. That's why there is no x. It would be x to the 0th. But, oh wait, don't erase that. So there's 3 terms, and we can see that the highest degree is 2. And this is called the standard form, when it's the exponents are from descending or in descending order. So let's look at this. So we have a degree and we have number of terms. So if we have 1, 2, 3, 4, 5, and yeah, I'll just do that. So if the degree is 1, it's linear. We already looked at that before, what that's like. 2, then quadratic. Quadratic function. 3, that's called cubic. Honestly, you should pretty much know this because we already went over parent functions. These ones you didn't really learn. Quartic and quintic. You'll learn a lot more about these and have to do things with them later in this lesson, or unit. So, number of terms, if there's only 1, then it's called a monomial. 2, binomial. 3, trinomial, and then why I grayed out that area or blacked out that area is because you don't typically see a name for things more than that. And the same goes for more than 5 for the degree. After there's 6, then you would just say degree of 6. You don't really need to say, I don't even know what it would be, but basically anything 2 and higher for the number of terms is considered a polynomial. So these don't have to go together. There doesn't have to be just a linear monomial, obviously. There could be a linear binomial or linear trinomial. Well, I guess not really, because then it wouldn't be simplified, but so don't think that. So this one would be, let's look here. We see that there's degree of 2, so it's a quadratic. 3 terms, trinomial. Quadratic, trinomial. So that's how you classify polynomials. Pretty simple. I mean, if you know the prefixes, mono meaning 1, bi meaning 2, tri meaning 3, and things like that, it's easy to remember. Now, based on what the leading degree and leading coefficient are, will change how a graph will look. So, here's what it can happen. If we have the leading degree, so let's just say LD. LD is even. What does that mean? Well, when it's even, that means basically that both arrows will point in the same direction. Doesn't matter if it's x to the second, x to the fourth, or x to the 1000th. If there is even leading power, which means basically like if you had something like this, it would still be even because there's the 4 and that's higher. If it's odd, then they point in different directions. So it could be like that, or like that, whatever the case may be. But you know how you see how I drew 2 different things here. What tells you if it's going to point up or down is the sign of the leading coefficient. So leading coefficient, if it is positive, for even, it will be like this, and for odd, it would be like this, or this. And I'm saying this, but we'll put in behaviors to that in a minute. So, but if it's negative, it's going to be point down, and it's going to be like this, or it's going to be like this. So that's just a little rule of thumb, as some call it. But let's see in behavior. So what is in behavior? That's kind of like a deceiving name because it doesn't really have to do with just the end of something, but it just means as the x values go to negative infinity, what do the y values do? And as x values go to positive infinity, what do y values do? So, for polynomials with even leading powers, these 2 things are going to be the same. If it's negative and even, then it's going to be like this. They'll both be negative. They're always the same if it's even. And if it happened to be positive, it would be like this. But if it's odd, these 2 things are going to be different. If the leading coefficient is negative and odd power, negative odd, then it's going to be opposite of what these 2 are. That's why it's negative. But if it's if it's odd and the leading coefficient is positive, then it's going to be the same as what the ones over here are. So let's look at how that would apply. So let's just take the function negative x cubed. Okay, so it would look something like this and about like that. And as we see that as x goes to negative infinity or to the left, y goes up. It's opposite. That's because it's negative. And they go in different directions because this is odd. So let's look at a different thing. How about this? This would be, maybe that would be negative x to the 8th. Well, it's negative because it's pointing down, and this is even. That's why the arrows are pointing in the same direction. So there you go. That's an intro to polynomials. You'll learn how to graph them and stuff like that later. But now I'm about to do lesson 14, the final review one. But I'll see you on that. But for now, just watch 2 through 13. So thank you for watching, and that'll be it.